Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Once again friends, I welcome you all in this very important series, Mastering Concepts, where we are having a very comprehensive preparation plan for upcoming GATE 2023. Yesterday we were having a very important session for your subject power system where we have discussed the weightage analysis, important books and the preparation strategy. And today we are going to start with the first concept, that is designing part of your transmission line, which is one of the very fundamental core concept of your subject power system. So all the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. So friends, today we are going to talk about concept 1, and that is designing part of your transmission line. Everybody who is joining me live, just quickly like the session, press the bell icon so that you do not miss any of the important class notifications, and do not forget to subscribe to BYJU'S Exam Prep English YouTube channel so that you are updated with all the important stuff related to your examination. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from BYJU in 2010. I have written a couple of books on engineering ethics and power system, and my expert areas are power system, electrical machines, electromagnetic field theory, material science, and obviously engineering ethics. Is it clear, everybody? Just tell me in the comment section, are you able to follow me? But before we start, a very important information, a proud statement from BYJU'S Exam Prep. Once again, BYJU'S Exam Prep has proved its exemplary result in the GATE examination. We have got 41 aspirants under rank 50, 11 aspirants under rank 10, and 74 aspirants under rank 100. And some of the top rankers, like in electronics, Ram Balaji rank 1, electrical Vandit Patel rank 2, and Parvinder Singh rank 3 in mechanical. And the list is not stopping. Now let us try to understand what is the agenda for today's session. What are the important areas where we are going to focus on in today's session? The first thing that we are going to discuss is the design consideration for transmission line. What are the important criteria we have to take care when we are talking about designing of our transmission line? The second thing we are going to talk about is the types of transmission line. So everybody just tell me in the comment section, are you ready, and shall we start the session? The first thing we are going to discuss is the design consideration. Now suppose as a power system engineer, if somebody is giving you a project, a task to design a transmission line for a given power system, what is the first question you are going to ask? The first question that you are going to ask is what material, what conductor material you are going to use for your transmission line. So the first question that you are going to talk about is the conductor material. Now, once you have decided the conductor material, the second important question that you are going to ask is what should be the shape and size of your transmission line? What is going to be the shape and size of your transmission line? Third important question that you are going to ask is what is going to be the voltage level at which you are going to operate your transmission line? The next thing is the insulation level and then you are going to talk about insulation. Now in today's lecture I will explain to you that there is a difference between insulation level and the insulation. We will discuss what it is. Okay. So these are some of the important criteria of design consideration, and after considering all these details, we are going to talk about what are the various types of transmission line conductors that we can use in our power system. Yes, Kilari, Geeta, Vagmi, everybody, welcome to the session once again. So let us try to understand the first part. But before that, let me tell you what is a transmission line. What is a transmission line and how we are defining our transmission line. See, in general, you can say that your transmission line is a conductor. The most simple understanding can be that your transmission line is simply a conductor. But it is not just like any other conductor. What type of conductor it is? It is a group of conductors to transport bulk amount of electrical power from where to where? From generating stations to the load centers. So everybody just tell me in the comment section, are you comfortable with this? What is a transmission line? Now the second thing we are going to talk about is what type of conductor material we are going to use for our transmission line. Now if you talk about the conductor material, you all must be aware that generally we are comparing the copper and the aluminum as a conductor material for our transmission line. So let us try to compare the copper and aluminum conductor. Now suppose we are saying for same resistance and length of line, if you are choosing the copper and the aluminum conductor, then how you are going to relate the cross-sectional areas of the aluminum and the copper conductor. You must be knowing that the resistance of the copper conductor you can write as rho copper L upon A copper, where rho copper is the resistivity of the copper material, and A copper is the cross-sectional area of the copper conductor. Similarly, you can write the resistance for the aluminum conductor as resistivity of the aluminum material L upon cross-sectional area of the aluminum conductor. Now for the given condition, if we are talking about the same resistance, just equate these two resistances. R copper is equal to R aluminum. You can write rho copper L upon A copper is equal to rho aluminum L upon A aluminum. Now you all must be aware that the resistivity of copper is going to be less than the resistivity of aluminum. So from this relation you can say that cross-sectional area of the aluminum conductor is going to be more than the cross-sectional area of the copper conductor. So what is the idea? The idea is, if you are going to design your transmission line by using a copper conductor, then it is going to look something like this, and if you are going to use aluminum, then it is going to look something like this. So what is the difference between these two designs? Let us understand that rho copper and not rho, let me use some another symbol, suppose Q. Suppose Q is the charge density on these two conductors, and we are saying for the same charge density, because your aluminum conductor is going to have a large cross-sectional area, or you can say more diameter is there, more radius is there. So you can say the electric field stress at the surface of the conductor is going to be less in case of aluminum in comparison to the electric field stress at the surface of the copper conductor. Now this electric field intensity is going to be a very important parameter for designing our transmission line, because at a very high voltage level, electric field stress gives you the nature or the intensity of corona, which is going to be a very important loss in your transmission line. So you can say, because of less electric field intensity, the possibility or the intensity of corona, you must be aware with the corona phenomena. If you are not aware, then you can ask me, is going to be less in case of aluminum conductor in comparison to copper conductor. And this is the main reason why we are opting aluminum over copper as a conductor material for designing our transmission line. So everybody who is live with me, just quickly tell me, are you able to follow this or not? If you are not comfortable with this corona phenomena, I can give you some idea about it. If you want to know what is the expression for this electric field intensity, then you can take it as V phase upon GMR ln GMD upon GMR. This is the general expression for defining the electric field stress at the surface of the conductor. Is it clear, everybody? Just tell me in the comment section, are you able to follow this? Yes, everybody, just tell me in the comment section, are you able to follow this? So we have completed what kind of conductor material we are going to choose. Now the second thing is shape and size of the transmission line. If you see the shape and size of transmission line, first we are going to focus on shape. See, if you are going to design a transmission line conductor, what is the most obvious choice of shape of the conductor that you are going to choose? Now some people will say, okay, Kilari is saying what is corona, so everybody just give me a yes comment so that I can tell you what is corona. Should I tell you what is corona? Yes? Let me give you some idea what is corona, then we will continue this. Suppose this is your transmission line. This is your transmission line. Okay, I have taken two nearby transmission line conductors. Now I will ask you some simple questions. Have you ever thought, when you get the first rain of the season, you feel something spiritual about it, you feel something different about it? When you go to the mountains, you feel something spiritual about it, you feel something different about it. When you go to the seashore, when you go to the riverfront, you feel something special about it. In Bollywood movies, they are saying it is a God symbol of love or something like that, but it is not like that. There is a science. What is the science? Always in our environment, because of various cosmic events and other reasons, there is excess of free electrons. Excess of free electrons are present in the environment, like when it rains, when you are in the mountains, when you are near the seashore, or when you are near the river bank. Now these excess of electrons give us a pleasant feeling, give us some spiritual feeling, and that is what we are thinking at love at first sight. So what is happening? Always there is excess of electron in the atmosphere. Is it clear, everybody? Just tell me in the comment section. Now because of the electric field stress, or you can say high voltage between these two transmission lines, if excess of electrons is there, what is the possibility? These are the excess of electrons. If the voltage between these two transmission line conductors, it becomes more than the critical disruptive voltage. In simple words, you can understand, if the voltage is very high, if the voltage is too high, then what will happen? The air media in between these two transmission line conductor is going to be ionized, or there will be a dielectric breakdown of the medium between the transmission line conductors. So what will happen because of this excess of electrons? If voltage is more than the critical disruptive voltage, electric field stress is going to be more than the dielectric strength. So what will happen? Dielectric breakdown. Now when dielectric breakdown will happen, what will happen? The medium between the transmission line conductor is going to be completely ionized. So some electrons will start flowing through the air medium also. This is what we are calling as complete ionization of medium between transmission line conductors. So this phenomena occurs as a power loss, which we are calling as corona phenomena. Everybody just tell me in the comment section, are you able to follow this? What is corona? I am just getting out of the frame. Just see it and tell me whether you are able to follow this or not. Kilari, are you getting this? What is this corona? I hope it is clear. Now let us talk about the shape of the transmission line. When you talk about the shape of the transmission line, in general, what is the first shape is going to come in your mind? That is going to be circular shape. Cross section I am asking, circular shape. Now there may be some power system engineers who are kg fail. You know who are kg fail? KG, you understand na? Kindergarten. So there are some candidates who are KG fail. So they are saying no, we don't like this circular shape. We like rectangular shape. They don't like this circular shape. They like rectangular shape. But what is the problem? The problem is, if you see the electric field stress at the sharp corners, electric field stress is going to be very high. We are saying at sharp corners, electric field stress is very high. So you are saying for these two cases, if you compare, E2 is going to be very high in comparison to E1. So you can say the possibility or the intensity of corona is going to be very high in case of second shape of the conductor in comparison to the first shape of the conductor. Is it clear, everybody? Just tell me in the comment section. Are you able to follow this? Now let us talk about the size of the transmission line conductor. If I ask you, in general, what size you are going to decide for your transmission line conductor? You want a small size transmission line conductor, or you want this much size transmission line conductor? Just tell me in the comment section. You have to be more proactive in the comment section. Then only there can be some positive consequence of these efforts. Otherwise, it is going to be waste. Tell me faster. You want a small cross-sectional area for your transmission line conductor, or you want a large cross-sectional area for your transmission line conductor? Now for common sense, just by using common sense, no electrical engineering required, you are going to say that we are going to have comparatively smaller cross-sectional area. Why? Suppose if you are having a large size conductor, then the weight of the conductor is going to be very high. When the weight of the conductor is going to be very high, definitely sag is going to be very high. Now what is this sag? Let me just give you some brief idea. Suppose this is your transmission tower. This is the cross arm. And suppose this is your transmission line conductor, something like this. So what is happening? this is what we are calling as sag, and if this is the ground level, then this we are calling as the ground clearance. I hope you must be aware with this. If not, then you can take a reference. Now, very obviously, when the weight is going to be very high, the sag in the transmission line conductor is going to be very large. When the sag is large, definitely the ground clearance is going to be less. But when you are operating at such a high voltage level, we are talking about 400 kilovolts, 765 kilovolts, 1200 kilovolts, then definitely there should be a minimum ground clearance. In order to maintain the minimum ground clearance, now the height of the tower you have to increase. Yes or no? Height of the tower you have to increase. So what is happening? Height and number of transmission towers you have to increase. So what is going to happen? The overall cost of setting up your transmission system is going to increase. Everything has some economy related to it, and that is why we are not preferring the large cross-sectional size conductor. We are preferring what? Physically realizable transmission line conductors. Physically realizable transmission line conductors. Is it clear, everybody? Just tell me in the comment section. Are you able to follow this? Now, the next thing we are going to talk about is the voltage level. Now, see, generally we are saying that we want to transmit electrical power at higher and higher voltage. Whatever higher voltage is possible, we want to transmit power at that voltage level. Now, what is the reason? Now, please try to understand. The first thing is, if the voltage is going to be very high for a given power, the current is going to be less. Yes or no? How we define current? Current we define as current density multiplied by the cross-sectional area. Now, this current density is constant for transmission line. For transmission line, current density is constant. For distribution system, it is not constant. Why? Because generally we do not connect loads in the transmission part. Generally, we connect loads to the primary or secondary distribution. Some particular big loads, industrial loads, we are connecting to the secondary transmission also, but generally in the transmission part we are not connecting load. So the current density is going to be constant. Now you are saying the current required is going to be less, so definitely the cross sectional area of the conductor is going to be less. It means you can have the economic size of the conductor, and at the same time the overall cost of your transmission system is going to be reduced. Is it clear? Now this is just one reason. This is just one reason. There are so many other reasons. Let us try to understand what are they. Second thing is, if you see the real power received at the load end. Suppose if you have a power system like this, this is a generator, this is your transmission line, and suppose this is your load. Now you are saying the real power received at the load end is P, and suppose this is V1 angle del and this is V2 angle 0, and suppose this is X. We are ignoring the resistance part. So what is the formula for this real power received? It is mod V1 mod V2 upon X sin del. Now if you see, in general, mod V1 and mod V2 are going to be same, especially if you are talking in terms of the per unit system. So you can say V1 and V2 are going to be approximately same when you talk in the per unit system. So can I say the power delivered or the power received at the load end is going to be directly proportional to the square of the voltage? Yes. It means higher and higher voltages we are going to use, more and more power we can transmit to the load end, and that is the reason we want to use whatever higher voltage level is possible, we are going to follow it. So you can say the power transfer capability is going to be increased. Is it clear, everybody? Just tell me in the comment section. You are not commenting, so I am little unhappy because you are very slow in commenting. Just tell me, are you getting this? Next, why we are operating at higher voltages? You are saying P is equal to P max sine del, where this P max we are defining as mod V1 mod V2 upon X, or you can say it is directly proportional to the square of the voltage. Now you want to transmit the power at a higher voltage level. It means this P max is going to be a higher value. Now if you are talking about the constant power delivered, if P max is increasing, definitely this sine del is reducing, or del is reducing. Now del is reducing means what? Del is reducing means what? If you see the power angle curve, this is del, this is P. If this is your power angle curve, it is going to be a sinusoidal one. This is going to be the P max value, and this is going to be del is equal to 90 degree. Now please try to understand, you are saying that you are having a very small value of del. It means what? The stability margin is going to be increased, or you can say the stability of the system is going to be increased. So a higher voltage level of your power system or transmission line is going to give you a more stable system. Everybody just tell me in the comment section, are you able to follow this? Is it clear, everybody? Just tell me in the comment section. Faster. Now we are going to talk about the insulation level. Now see, when we talk about the insulation level, we are talking about the maximum possible voltages which may occur in our system. They may not be occurring, but the possibility of the maximum possible voltages, that is what we are considering when we are talking about insulation level. Actually, we want to protect our transmission line or the power system in case of these highest possible voltages which may occur in the system. So insulation level is required to protect the system against the highest or the maximum possible voltages in the system. Now what can be the maximum possible voltages in your system? There can be two types of voltages which may be present in your system. The first one is lightning over voltage, and the second one is switching over voltage. Now let us first discuss about the lightning over voltages. See what is happening. If this is your transmission tower Okay, suppose this is your transmission line conductor, and suppose there are some clouds. See my beautiful drawing. These are the clouds. Now what is happening? Because of the friction in the clouds, some static charges are going to be developed in the clouds, and these static charges are so huge, so high, that the moment they get a conducting path on the ground, all these static charges, they are discharged in no time. And this is what we are saying, the striking of lightning, or lightning stroke. Are you getting this? So what is this happening here? This lightning stroke is going to occur here. Now because it is a discharge of bulk amount of static charges within no time, so it is going to be represented in the form of a discharge current. Now it is not necessary that it is happening at the middle of the transmission line. I am just showing you like that. It may be anywhere on your transmission line. But whenever there is going to be extreme conditions, the behavior of the transmission line is always going to be with respect to the surge impedance. When we will talk about surge impedance, then we will talk in detail, but you understand that when we talk about surge impedance, we are defining it as under root L upon C, where L is the series inductance of the transmission line and C is the shunt capacitance of the transmission line. And this surge impedance is independent of the length of the transmission line, because there is no length term. So when the surge impedance is going to be independent of the length of the line, it means it is immaterial at what point this discharge is going to happen. The impedance seen by this discharge current is going to be same both the sides. So by using this path, this lightning discharge current is going to be going to the ground. So now if you want to see what kind of lightning over voltage may be present in your system, so I can tell you, if this is point P, then what is going to be the maximum possible over voltage which may be present in your system. If this is IC, then definitely the current going to these two paths is going to be 1/2 IC and 1/2 IC. What is the reason? Because the impedance seen by the discharge current towards both the sides of the conductor is going to be same, that is the surge impedance. So this discharge current is going to be divided equally. So the potential of this point P where the discharge has occurred, it is going to be 1/2 IC into ZC. You may get a direct question on this concept in the gate examination. Is it clear, everybody? Just tell me in the comment section. I am not getting your comments. I don't know why you are so inactive in putting your comments. Is it clear, everybody? Just tell me in the comment section. So this is your lightning over voltage. Now let us talk about the switching over voltage. Now you see, because of opening or closing of circuit breaker and switching on or off of heavy loads in the system, always there is a possibility of very high switching over voltages which may be present in your system. Now a very classical question is asked in your examination, that which over voltage is going to be more dangerous, and while designing our transmission line, which over voltage we should consider. So in general you can conclude, that for voltage in general less than 300 kilovolt, lightning over voltage is going to be more dangerous than the switching over voltages. But for voltages more than 300 kilovolts, switching over voltages are the deciding criteria for insulation level. Now you may ask, sir, why it is so? Because lightning is going to be a very high over voltage. So why more than 300 kilovolts? In some of the books, some of the literature, you may find it 220 kilovolts also. So I am just taking a random value. Do not stick to the factual details. There may be little bit variation in them, but the concept is clear. What is happening when you are operating at a very high voltage? Because switching over voltage is an internal phenomena, it is very difficult to manage it, to control it, because it is the internal phenomena. Whereas lightning over voltage, this is going to be external phenomena. For example, in order to protect your system with the lightning, what we are doing? We are using the ground wire. Some of you might have read it. What we are doing? We are putting a conductor at the top of your transmission tower. So if the lightning is going to happen, the lightning will stuck at this ground wire. This is called ground wire. It is at the top position. Why it is called as ground wire? Because it gives a passage to the lightning stroke to the ground. So it is called as ground wire. Is it clear? So at a higher voltage, switching over voltages are going to be the deciding criteria for insulation level. Now let me talk about the insulation. Now see, when we have defined insulation level, then we are saying it is required to protect the system against the maximum possible voltages, or you can say over voltages in the system, maximum possible over voltages in that system. But when we talk about the insulation, we are trying to protect the system against operating voltage, For example, if this is your transmission tower, this is the cross arm, and suppose these are the insulators, suspension type string insulators, and this is your transmission line. Now this transmission line needs to be contained so that there is no direct contact of this transmission line conductor, because it is operating at a very high dangerous voltage level to the nearby human beings, yes or no? Otherwise there will be loss of life and damage. So if you see, the leakage current is going to be something like this, yes or no? This is going to be the leakage current path. If this conductor is operating at this voltage, then we want to protect our system with this operating voltage, against this operating voltage. Is it clear? Now suppose you are saying that you have a 220 kilovolt line. So what should be the insulation required? Now you please understand one thing. When you talk about the insulation, you are talking about the peak per phase voltage. You must be knowing why I am saying per phase, because when you talk about the insulator, you are talking about a single phase conductor only. Why we are talking about the peak value? Because if you want to protect your system, if you can protect it for the peak value, for the rest of the values it is automatically protected. Now when the rating, the voltage rating of the transmission line is given as 220 kilovolt, you please understand this is the RMS line voltage. Are you getting this? So the first thing we have to do is this 220 kilovolt, we have to convert it into the per phase voltage. Line voltage divided by √3 will give you the per phase voltage. But again, this is the RMS value for one individual phase, but you require a peak value. So if you want the maximum value, you have the RMS value. What you do? You just multiply the RMS value with √2 and you will get the peak value. So actually you have to protect your system against this voltage. Is it clear, everybody? Just tell me in the comment section, are you able to follow this? Is it clear, everybody? I hope you are able to follow this. Yes, Geeta? So this is how we have completed the design consideration of our transmission line. Okay, now let us talk a little bit about the types of transmission line conductor. We don't have much time, so let me see maximum what we can do. When you talk about the types of transmission line conductors, the first type of transmission line conductor that you can have is single solid conductor. Single solid conductor is going to be something like this. It is going to be circular cross section and it is going to be cylindrical. Now there are some advantages and some disadvantages. What is the advantage? What is the advantage? Advantage is that mechanical strength is going to be very high. When mechanical strength is very high, it means what? The sag in the transmission line conductor is going to be less. When sag is less, ground clearance is going to be more. When ground clearance is more, the height and the number of tower is going to be comparatively less. Height and number of towers is going to be comparatively less. So overall you can say cost is going to be less. These are the advantages. Now let us see what are the disadvantages. The disadvantage is going to be skin effect. Everybody in the comment section, just tell me whether you are comfortable with skin effect or not. Geeta is saying, sir, please once explain voltage effect. Where you want me to explain voltage effect? I have never used voltage effect. There is nothing like voltage effect. Tell me exactly what you want. You want this insulation to be explained again or something else? Okay, so Mr. BT Ramya is saying explain a skin effect. Now see what is happening. Suppose you have a transmission line conductor like this. Is it clear? And this is going to have AC current, which I am going to define like this. Now because this is going to be AC current, this cylinder is okay for you? Is it okay? Now because this is current, this current is going to have some magnetic flux. By using the right hand thumb rule, thumb in the direction of current and fingers moving of the right hand will give you the direction of magnetic flux. So the magnetic flux is going to be something like this. And because the current is going from bottom to top, the fingers will be crossing like this. This side it is going to be in this direction and this side it is going to be in this direction. In order to make you comfortable with this, you can say the magnetic flux lines are entering at the right side. So I am putting a cross here. Cross means the magnetic field lines, the magnetic flux lines, they are entering into the plane of the screen. At the left hand side, they are coming out of the plane of the screen. So I am putting a dot. What is happening here? If you have AC current, the magnetic flux is also going to be alternating. Yes or no? If the current is alternating, then the flux is also going to be alternating. Alternating flux means time varying flux. The moment you say time varying flux, it means what is going to happen? Faraday's law. If a time varying flux is linked with a conductor, some EMF is going to be induced. Now this EMF, if it founds a complete channel or path, it is going to circulate a current. That current we are calling as eddy current. Now let us see the direction of eddy current. Now you just imagine from your common sense, what should be the direction of eddy current? As per the Lenz's law, the direction of eddy current will be such that the effect opposes the cause. What is the effect? The effect is the generation of eddy current. What is the cause? The cause is the flux, time varying flux. So because the flux lines are going into the plane of the screen at the right hand side, the eddy current at this part is going to be such that they are going to give rise to a flux which is coming out of the plane of the screen. Are you getting this or not? So where you want the flux direction? Right hand side, outside, to oppose this time varying flux. So put your right hand thumb out of the plane of the screen and fingers moving will give you the direction of eddy current. Are you getting this or not? Similarly, you can find the direction of eddy current for the left hand side also. Here the magnetic flux, time varying magnetic flux is coming out. So you want a flux from the eddy current which is going into the plane of the screen. So keep your right hand thumb into the plane of the screen and fingers moving will give you the direction of eddy current. So it is going to be something like this. Now this is not happening just at these 2 points. It is happening all across the cross section of the conductor. So in general you can say the regions which are near to the surface of the conductor, there is a crowding of current. There is a crowding of current. The current is more because this current and this current, the main current and the eddy current, they are in the same direction near the surface of the conductor. But if you come to the core of the conductor, in the core or the central part of the conductor, the eddy current direction and the main current direction is opposite. So what is happening? In your transmission line conductor, the effective current is present only up to a certain distance from the surface of the transmission line conductor, and this distance we are calling as skin depth. Now suppose you have an ideal conductor. If you have the ideal conductor, then this skin depth is going to be 0. It means the current is only present on the surface of the conductor, skin of the conductor. Skin of the conductor or surface of the conductor. That is why this effect is called as skin effect. Now what is the problem with this effect? The problem with this effect is that when I am writing the resistance formula, I am writing rho L upon A. Now what is this rho here? This rho is the resistivity of the conductor material, which is a characteristic, so we can't change it, it is fixed. L is not simply the length of the conductor. L is the length of the conductor in the direction of current. L is the length of the conductor in the direction of current. I hope you understand this. Now, what is this A? This A is the cross-sectional area perpendicular to the direction of current in which current is present. In which current is present? Because of the skin effect, in the central or the core part of the conductor, no current is present. The current is only crowding near the surface of the conductor. So you can say this electrical area has been severely reduced. When this electrical area has been severely reduced, you can say the resistance is going to be increased, and this is the reason we are saying because of skin effect, the AC resistance is more than DC resistance. And this is what we call as skin effect. Suppose you have a DC. If you have a DC, the current is going to be uniformly distributed across the cross-sectional area of the conductor. So this resistance you can represent as rho L upon A. Is it clear, everybody? Now this physical area of the conductor is going to be more in comparison to this electrical area in case of AC current. Is it clear, everybody? Just tell me in the comment section, are you able to follow this? What is skin effect? Is it clear? Everybody just tell me in the comment section. Are you comfortable now? What is skin effect? Now, we were talking about the single solid conductor. The mechanical strength is going to be high. Mechanical strength high means the sag in the conductor is going to be less. When the sag is less, the ground clearance is more. When ground clearance is more, the height of the transmission tower and the number of transmission tower is going to be less. So ultimately the cost of transmission line or transmission system is going to be less. There is one big disadvantage, that is skin effect is going to be very high. Because of skin effect, the AC resistance of the conductor is going to be higher than the DC resistance. More resistance means more ohmic losses. More ohmic losses means less efficiency. This is the case. Now, in order to reduce this disadvantage, what we are going to do, we are going to use the stranded conductors. Stranded conductors. Now, what is this stranded conductors? Instead of using a conductor like this, I am showing you the cross-sectional area. We are going to use a smaller cross-section strands. Are you getting this? We are using a smaller cross-section strand so that the skin effect is reduced. Now, please mark my words very carefully. Every single word I am telling you is going to be very important for your examination. Skin effect is reduced. I am not saying it is removed. I am not saying it is removed. I am saying it is reduced. It means still the skin effect is present. Second, mechanical strength is reduced. Mechanical strength is reduced. Third, because of this irregular surface or the sharp corners, corona or the possibility of corona or the intensity of corona is increased. It means you were going to solve some problem, but instead of solving that problem completely, you have given rise to some more problems. What are those more problems? Number one, mechanical strength has reduced, and number two, corona is also increased. Now, the first thing we are going to do is we are going to increase the mechanical strength. How? We are going to increase the mechanical strength by using the ACSR conductors. It is called as steel reinforced aluminum conductor. What is this? I told you that this stranded conductor skin effect is reduced, it is not removed. It means still the core strand is not going to have any significant current. So what I am going to do is I will remove this core strand, that is aluminum, and I will place a steel strand. A steel strand is not going to carry any current, but it is going to give you mechanical strength to your conductor. So what is happening? Your ACSR conductor is going to look something like this. This is going to be a steel strand and this is going to be aluminum strand. Is it clear, everybody? Just tell me in the comment section. Mr. Ramya, already in the starting part of our discussion, I have discussed what is corona phenomena. You please watch it again after the session and I hope you will understand. But still, if you don't understand, you can join my personal Telegram channel on BYJU'S exam prep and you can ask any number of doubts there. Is it clear? So by using this ACR conductor, what we are doing actually, by putting the steel strand at the core part, we are increasing the mechanical strength. But again, we have got one problem remaining, that is corona. How to reduce the corona? Now, in order to reduce the corona, we are having another type of conductor, that is bundled conductor. Bundled conductor. What we are doing? Even instead of having one single solid conductor or smaller strand conductors, we are having more number of subconductors and giving them some spacing. Now, why we are giving them some spacing? Please try to understand. This S is the spacing between these two subconductors. They are called as subconductors. Now, if you are aware about the concept of GMR, geometrical mean radius, then you will understand that by giving the spacing in between the subconductors, actually you are increasing GMR. So actually we want to increase the GMR. Now you will say, sir, why you want to increase the GMR? We want to increase the GMR because the electric field stress is given as V phase upon GMR ln GMD upon GMR. Now this is a logarithmic term. So if GMR is going to be increased, electric field stress is going to be reduced and you can say corona is going to be reduced. Is it clear, everybody? Just tell me in the comment section. So that is the reason we are using the bundled conductor system. The last type of conductor that we are using is hollow conductor. Now, hollow conductor is something like this. Number of strands are arranged at the circular periphery of a hollow conductor, and this design was first suggested by a company named Anaconda, and on the name of that company these type of conductors are called as Anaconda conductor. They are still at the experimental stage because of various reasons of mechanical strength or the stability, but they are going to be the future transmission line conductors for very sure. So this is all about today's session. Now tomorrow we are going to have a lot of important problem solving. So do not miss tomorrow's session. Whatever we have read today and some more also we are going to take and we are going to solve important problems on that. Do not forget to comment in the recorded video. This video is going to be available for your reference. You can comment any of your doubts. I will be more than happy to answer your doubts. But still you want to connect with me and you want to have some direction, some help, some guidance from my side, you can join my personal Telegram channel on BYJU'S exam prep, that is Electrical by Ashutosh Saxena. So thank you so much friends for joining me live in the discussion. I hope you enjoyed the session. No, Geeta, this is not the full course. We are discussing some important concepts, related questions. but we are covering all the subjects. This is going to be a long comprehensive preparation series. We have started quite early, quite back. You can follow the sessions and you can learn a lot of concepts. Mr. Bitu Raja is saying, where can I find your whole power system lectures, sir? You can follow the same channel, BYJU'S Exam Prep playlist. You can go and you can find my previous sessions, and if you are not able to find them, I will send you the complete link of those sessions. You can simply join my personal Telegram channel. I will give you the link for those sessions. Thank you so much. Take care of yourself and let us meet tomorrow and solve some important problems. Thank you so much. All the best. Stay connected. Thank you. Forever is saying, why are not used for higher voltage transferred with the help of aluminum conductor? Aluminum conductor have negative temperature coefficient. Forever, I think first you frame your question in a proper way. Let me just give you some idea that we are using some composite conductor materials also, but they are for very specific applications. Are you getting that? But in general, we are using the aluminum as the base material for your transmission line conductors. Thank you so much, everyone. Take care. Thank you.